Alright, let's start solving. First things first, for both logs and for exponentials, if you have the same base on both sides, or you have the same log, like everything has this base, or everything has this base log, remember we can cancel it out. So like number 12, we've got 7s. So we can just go yoink, x minus 3 equals 2x minus 8. I know, hard as can be. And then move your x's one way and your numbers the other. So like I'm going to move my x's to the right, and I'll move my numbers to the left. So that is 8, 7, 6, 5, 5 equals x. Done. Cool. 13, same idea. 13 is the same idea, except we don't have the same base at the moment, so we're going to get the same base. These are both multiples of 2. So like 16 is 2 to the 4th power, and 8 is 2 to the 3rd power. Okay? Just remember that I need to multiply this new exponent, like over here I need to multiply this 4 by the old one. So that's 4 times 2x minus 3. Just like over here, this is a 3 times x plus 7. Okay? Now I have the same base, so I can go yoink. And so I've got, and I'm going to go ahead and distribute while I'm at it. So 4 times 2 is 8x, 4 times 3 is negative 12, equals 3 times x is 3x, 3 times 7 is 21. And then I'm going to start solving again. So x is one way, numbers to the left. I'm going to move the x's left this time. I like to leave my x's positive if I can. Plus 12, because it just makes life easy. 8 minus 3 is 5. Yeah, 5x. Let's go back to stay consistent. 8 minus 3 is 5x. 21 plus 12 is 33. So, oh, look, we get a fraction. Who cares? 33 over 5. Just leave it as a fraction. Cool. Alright, turn the page. Let's keep rolling. Oh, looky here. Looky here. Number 14, same idea. Alright, this one's a little bit different. But it's the same basic premises. So for both of these, they're both multiples of 3. Alright, the difference is this one. Remember, to bring that is a negative exponent. Alright, to bring this 3 to the top, nope, I don't want to review student questions. There are no student questions. At least not at 5:27 in the morning. So this 3 needs to be moved up, so that becomes a 3 to the negative 1. And I'll multiply it by its old exponent. Okay? 81 is 3 to the 4th. And I'm going to multiply by the old exponent. Cool? And from here, I'm confident you can do it on your own. If you can't, we need to talk. And that's okay. But, here we go. So that's 4x minus 20. I'll move the 4 over, so I'll subtract 4x. That's negative 5x equals negative 20. I love my 5 right there. Let's clean that up. Negative 5x. I'm not sure that's any better. Whatever. X equals 4. And you're done. Okay. Number 15. Number 15 is the exact same premise. You notice how both of these have the exact same log. Yeah, they do. So I can go like this. Yoink, yoink. All right, and everything has a log. It's not like an extra plus 2 out here or something along those lines. They are the same log. So this is just 2x equals x squared minus 8. All right, that's the premise of the log. The rest of this, it does get longer than this because of the x squared. Now, you have an x squared and an x. So this we have to solve by factoring or the quadratic formula or something along those lines. So get everything to one side and factor. So I'm going to subtract that 2x, so I got 0 equals x squared minus 2x minus 8. Put up your parentheses, do. All right. Remember, the left side multiplies to the left, right side multiplies to the right. So the left side is an x squared, so I'm going to go x and x. The right side is a negative 8. So that's 8 times 1 or 4 times 2. I'm going to try 4 times 2. And I got to multiply to a negative 2, so that would be the correct combination. Cool. because negative 4 plus 2. And the way you check is x times 2 is 2x, x times negative 4, that's the inside, is negative 4. Outside, inside, they add up to the middle. Negative 4 plus 2 is negative 2. Hey look, that's the middle term. Then we did it right. Cool. And again, this part over here is chicken scratch, so if you don't write it down, that's fine. The rest of this you need to write down. So last but not least, if you don't show this last part, that's fine. So this x minus 4 equals 0, so x equals 4. X plus 2 equals 0, so that's x equals negative 2. Again, if you can do this part right here in your head, that's fine. So those are your two answers. Now remember, whenever you're solving a quadratic, part of the problem is it can give you answers that do not work. So you always have to plug them back in. Now the nice thing is log, we don't have to solve the whole thing. That's fine. But what we do need to do is we do just need to plug in and make sure we get a positive argument. Alright, what I mean is this number right here has to come out to a positive number. Both of them do. So if I plug in a negative 2, 2 times negative 2 is negative 4. You cannot have log base 3 of a negative 4. It does not work. That just does not exist. So therefore, the minus 2 is out. Whereas the 4 is fine, so 2 times 4 is 8. And over here, 4 squared is 16 minus 8. Well, that's also positive. So that is your answer. Okay? So let's recap real quick on this one. All right? Getting rid of the logs, one step, that's fine. All right? That's the trick with the log. This one just had a quadratic mixed into it. So the rest of this was back in chapter 4 when you were solving quadratics. Alright, the only thing new was that first step. Alright, let's keep rolling. Number 16. Okay, cool. These all have logs, so we're going to try and cancel them out. But we need to condense these two first. We need to bring those two together. Remember, if they're positive, they go on top. If they're negative, they go on bottom. So we're going to multiply those suckers. So that's log of x times x minus 4 equals log of 12. Now we have the same log on both sides, right? So, well, I'm going to go ahead and just do this so it's a little cleaner. Log of x squared minus 4x equals log of 12. And hopefully you can already see where I'm going with this. What we can do is we now can cancel the log. And we get x squared minus 4x equals 12. Now, if we didn't have the quadratic, we would be done real quick, but we do. So this is just like the last problem. Get everything to one side and factor. So you've got x squared minus 4x. My dog is under the table sticking their nose at me, going, please pet me, please pet me. Actually more, please throw the ball, please throw the ball. Anyways, so there's your quadratic. Put up your parentheses. Put up your parentheses. Left side multiplies to the left, right side multiplies to the right, outside inside goes to the middle. So left side goes to the left, so x squared, well that's an x and x. Right side goes to the right, negative 12, that's either a 6 and a 2, a 4 and a 3. I think it's going to be 6 and 2 actually. And I think it's going to go like that. So left to left, right to right, outside inside adds up to the middle, so x times 2 is 2x. Negative 6 times x is negative 6x, those add up to negative 4. Yay, that's my middle term. Okay, and this part in green, and you don't have to write that down, that's your chicken scratch. But that's what we did. So again, set them equal to 0. X minus 6 equals 0, so x equals 6. X plus 2 equals 0, so x equals negative 2. And remember, we got to check them out. So plug them in. If I plug in a 6 for this, we're good. If I plug in a 6, 6 minus 4 is 2, so the 6 is good. The negative 2, log of negative 2, can't have a negative argument, so the negative 2 is out. Cool. How many more solving ones do we have? Like 15 of them? Ooh, please tell me there's only 3. Oh, crud. Okay, we'll pause the video after these next 3. Alright, so these ones, the next 3, you notice how these don't all, like, you can't get a common base with 5 and 9. Or this one has a log, but that one doesn't. These two have logs, but that one doesn't. Alright, so we can't use the trick that we've been doing. Well, it's not really a trick, it's just a property. we can't use what we've been doing. We need to switch them into and out of logs. Here's what I mean by that. Number 17. Got this base alone. So I need to popcorn it back into a log. So that's log base 5. Go across the equal sign of 9 equals your exponent, x plus 3. And then solve. The only thing you got to do is move the 3. So it becomes a negative 3 plus log base 5 of 9 equals x. And that's your answer. Now I stuck the negative 3 out front. And the reason why is you don't want to merge it with the 9. If you write it like this, log base 5 of 9 minus 3, your biggest temptation, and my pen just broke, is to combine these two and make it log base 5 of 6. I'm tired. Yeah, you can't do that. You cannot break into a log like that. Alright, so don't do it. So just stick it out front. It's kind of the proper way of writing it, but whatever. Alright, 18, same idea, except we have a log. So we need to go from a log to an exponential. Remember, base, go across the equal sign, come back. Popcorn it out. Base, go across the equal sign, and come back. So that's 7 to the second equals x plus 4. So I'll subtract, that's 49 equals x plus 4. Subtract the 4, that's 45 equals x. Done. Cool. Alright, number 19. This video is getting a little long. Number 19, again, this doesn't have a log, so we can't cancel them out. We just have to combine them. Okay? So what I'm going to do is I'm going to start by combining these two. They're both positive, so they're both in the numerator. They're going to multiply. So it's log base 2 of x squared minus 14x equals 5. Now we can popcorn it. So 2 to the 5th equals all that. So 2 to the 5th power, which is 32, and x squared minus 14x. We got rid of the log. Yay! So hopefully you're starting to see now that, oh crud, this is where we have to multiply the whole thing out, factor it out. No, 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 no. Mr. Hunter, why'd you give us another one of these? Because you need the practice. That's why. Some of you can do these in your sleep. Some people can do these to save their lives. So I'll subtract the 5 squared, the 2 to the 5th, so that's a 32. So that's 0 equals x squared minus 14x minus 32. Factor that sucker down, that's 0 equals, and pause the video, see if you can do this on your own, but I'm going to keep moving. That's going to be 2 things that multiply to the left, are x and x. 2 things that multiply to 32, well that could be an 8 and 8 times 4. I think it's actually going to be 16 times 2. Because of the 14. I'm trying to get back to a 14, that's why I think it's that. Because that's a negative 16x and a positive 2x, which equals negative 14. Yep, that was right. Yoink. Get rid of all that. What am I saying? Oh, so in this case, you got x equals 16 and x equals negative 2. So if I plug those in, 16 minus 14 is positive. 16 is positive, so that's good. Negative 2, oh, that's a negative argument. So that guy's out. Now you might be starting to think the negative one is always out, and a lot of times that's true. But what if you had log base 2 of negative x? When I plug in the 16, well, that's a negative 16 on the inside. Can't do that. If I plug in the negative 2, well, that's a negative negative 2, which turns it into a log base 2 of positive 2. So here's my point. Just because your answer came out negative does not necessarily mean it's the one to get canceled. If you had a log that looked like this, the negative 2 would be in and the 16 would be out. All right? Don't just necessarily discount that. All right, this video is getting long.